My dear friends, welcome back to B Spice. In this session, we'll continue with gas detection technologies, wherein we'll focus on non dispersive infrared open path. So, this is the look and feel of the open path. If you are a first time viewer, just wanted to share, friends, we have been covering this gas detection technologies for the past few sessions. In fact, you see, first we started off with the terms and definition on this gas detection technologies. Then we uploaded a video on catalytic bead type, then followed by the metal oxide semiconductor, and the last video we talked about the same subject, non-dispersive infrared, but that was point type. Okay, and this is about open path. Let's see the details. Okay. See, as I said, the technology is non-dispersive infrared open path. As you can see here, this transmitter, and this is your receiver, right? Source detector. So the wave, the beam is passed through open path. So there in the point type, it was particular to that particular point actually. Okay, that's a difference. So again, the gas type detector is combustible gas. And principle of operation, yes, it's operates similar to the point type infrared detector, except that the IR source is separated from the detector, meaning you see here, this is the IR source and this is your detector, right? So this is separated actually. That is what. So if we talk about the description, friends, see, open path IR monitor expand the concept of point IR detection to a gas sampling path of 150 meters. So there, that was only to a point actually. It will deflect on the point and then get reflected, right? So here it is, the sampling path up to 150 meters actually. The diagram says 100 meters, but we can go up to 150 meters. So like IR monitor, they utilize a dual beam concept, meaning the sample beam is in the infrared wavelength which absorb the hydrocarbon, and the second reference beam is outside this gas absorbing wavelength. So the ratio of these two beams is continuously compared. Okay, two beams means the sample beam and the reference beam. Okay, right. When no gas is present, the signal ratio is constant. When there is no gas here, the signal ratio will be constant. When a gas cloud, as you can see here, when a gas cloud crosses the beam, okay, when a gas cloud crosses the beam, the sample signal is absorbed or reduced in proportion to the amount of gas present, while the reference beam is not. Okay. So system calculates the product of the average gas concentration and gas cloud width, and readings are given in percentage LEL per meter. This is the principle, friends. LEL per meter, lower explosive limit per meter. Okay, right. So when we talk about the pros, yes, it is high accuracy, selectivity, similar to point type. Yeah, large measurement range, yes, similar to the point type. Yes, it's low maintenance, very good news, similar to point type. Yes, it's highly resistant to chemical poison, unlike, the semiconductor, right? That one was subjected to poison, but here we don't have that challenges. And it does not require oxygen, air or something. And of course, the span drift potential virtually eliminated, meaning no routine calibration. Almost from same as the point type, fail safe, all these. Except that this is expanded up to 150 meters. It is not particular point. It is, coverage up to 150 meters. That's the difference. And when we talk about the limitation, yes, it's not suitable for hydrogen detection. And compared with IR detection, this is not capable of isolating the leak source, and it requires unobstructed path between the source and detector. Here, that is a challenge. Source and detector, if there is any obstructions, right, then it will not work because the beam will get deflected. So longer path can be more difficult to align, may be susceptible to beam block. That's what I said. If anything is blocked here, then this is a challenge actually. It will result in the loss of IR signal, and it will not work actually. Right. And also in the heavy fog or rain, this may not be suitable, friends. So this all about the gas detection, non-dispersive infrared open path, friends. So thanks again for all your support, friends. Keep supporting and keep watching. So next, what I'm going to talk is about the tunable laser diode absorption spectroscopy open path. Tunable laser diode absorption spectroscopy open path. Okay, right. Thank you. See you.